Alright, so in this video we're going to continue looking at rigid transformations. Alright, so remember the last video we looked at rigidness, what it meant to be rigid. Rigid just means not changing the shape or the size. Alright, all we're going to be doing is changing the position of the figure that we're moving around. Okay, and of course we're moving something around, that's what the transformation stood for. We're just transforming something. Alright, same standard, okay, rigid transformations. Now let's look at the second type of rigid transformation. So the past video we looked at translations. Now we're looking at rotations, okay? So what is a rotation? A rotation is when you turn an object either clockwise, okay, so we're turning it like this, or counterclockwise, so you're turning it like this, okay? Clockwise, like a hands on a clock, counterclockwise, okay? A certain number of degrees, all right? So now what's important again are the key concepts, okay? So lines are taken to lines. So the same concepts hold for rotations. The same ones that held for translations also hold for rotations. All right, because rotations are another form of rigid transformations that preserve line segments, the length of the line, and it preserves angle measure, and it preserves parallel lines. Okay, so just like in the last video, let's look at this example. All right, so we had this little rectangle, this rectangle A, with angles 1, 2, 3, and 4. All right. So instead of sliding it around, now we can rotate it. Okay. So maybe we can rotate this rectangle A like this, right? Or we could rotate it like this. Okay. Or we could rotate it back over the origin, back to where it was. Or we could rotate. We could end up with something like this. All right. So let's look at this for a second. Okay, and let's look at the key concepts and how they correlate with this A and this A prime. Okay, when I say A prime, I just mean the new one. Well, this is the original. A prime is the new one that we got to. All right. So now we can look at the key concepts. Okay, and it says lines are taken to lines, and line segments are taken to line segments of the same length. All right, and obviously we can see that this line here, 1, 4, is still the same distance as this 1, 4. Okay. This 1, 2 right here, this line 1, 2 is the same thing as this line segment 1, 2. This line segment 2, 3 is the same distance as this line segment 2, 3. Okay, same thing for 3, 4. All right, so line segments, the distance stays the same between each line segment. All right, so now we can look at angles, right? We can look at the angles also. Angle 1 stayed angle 1. Angle 1 was a right angle here. It's still a right angle here. Okay, angle 2 was a right angle. Angle 2 was still a right angle, even though we rotated it. Okay, 3 is still 3. 4 is still the same measure as 4. Okay, so that's what it means. Angle size doesn't change when rotating. Okay, just like angle size didn't change when translating, angle size doesn't change when rotating. And lastly, we can look at parallel lines, and then we can say parallel lines are taken to parallel lines. What that means is, if you look at this line 1, 4 and this line 2, 3, up here we can see that they're parallel, right? We can see that these lines are never going to cross if we extend them to go up, up, and further down, right? These lines are never cross. And even if we rotate it, it's the same thing is still true, right? Here's 1, 4 now, and here's 2, 3. These lines are still parallel. They're never going to cross. Same thing with 1, 2, and 3, 4, right? They're going like this. They're never going to cross. And even though we rotated it, we still get 1, 2, and 4, 3 to be parallel. Okay, so that's what it means when it says parallel lines are taken to parallel lines. Okay, it just means that it's being preserved. Okay, so far we have translations and rotations that are being preserved. So we can look at another couple objects. For example, this diamond here, this diamond A, and maybe we rotated it to look like this. Okay, or maybe let's say we rotated it to look like, or sideways. How about? Even better. It's the same thing. Okay, so now this is the rotated figure. Rotated figure, right? And notice, even though, so let's go one by one. So the lines are taken to lines, right? Angle 1, 4. Okay, we rotated it, but the distance is still the same. Line segment 2, 3. 2, 3 is still the same length as 2, 3, even though we rotated it. Okay, that's what it means to be rigid. Same thing with 3, 4, and the rest of the sides. All right, angles are still the same, right? All we're doing is turning something around. So angle 1 measured whatever the measure was here. It's still the same measure here. Angle 2 is still the same measure of angle 2. Angle 3 is still the same measure as angle 3. Same thing with angle 4. Okay, so the angle measure stayed the same. All right. Parallel lines were taken to parallel lines, just like it was for the rectangle. Right. For the rectangle, we had something like this, right, where these parallel lines matched up here. This parallel line matched up with these parallel lines. Same thing here. So we could have the line 3, 4, which is parallel to 1, 2, right? So these two lines are parallel. So 1, 2 now is here, and 3, 4 is here. But these two lines are still parallel, so they're still not going to intersect. Okay? So now what we can say is we can say that let's go back to the rectangle. We could say that we can now do like a combination, right? We could do a combination of a translation and a rotation. And no matter how we combine them, so for example, if I slide down, slide right, then slide up, and then rotate, let's say, 90 degrees counterclockwise, it doesn't matter. The lines are still the same length, okay? The angles still stayed the same, okay? The parallel lines are still parallel lines. So now we know that maybe we can say that any sequence, okay? Maybe we could say here, maybe we can say any sequence of translations followed or preceded, right? Because it doesn't matter what order you go in. So you could translate first and then rotate and still get everything to be the same, or you could rotate first and then translate and everything still remains the same. So maybe we'll say any sequence of translations followed or preceded by rotations preserves. We'll say preserves lengths, angles, and parallel lines. Okay, so now we see that we can mix with the translations and the rotations, and we're still going to preserve everything. Okay, so it doesn't matter if we translate 500 times to the right or 700 times to the left, and then flip it 90 degrees to the left, and then flip it 90 again to the right. It doesn't matter. Okay, everything's still the key concepts are still gonna apply because what we're doing are rigid transformations. That's the key here is rigidness. Is we have rigidness. Okay, so in the next video, we're going to see that we can add another one, which is going to be reflection to the translations now, and then the rotations. Okay, so we're going to have a third one. All right, see you guys in the next video. Thanks.